In this video, we'd like to take a look at searching through sequences to determine not only the index position of an item in a sequence, but also simply whether or not an item is in a sequence as well. And we'll use a combination of methods and operators to demonstrate these concepts in this video. So let's start out with a list called numbers, and the technique that I'm about to introduce to you using an index method of the list will also work for tuples and for strings as well. Each of those types has an index method that allows you to search the collection of items, whether it's a list of values, a tuple of values, or a string of characters, and determine the position of a given value within that sequence. So we'll go ahead and create this list called numbers, and let's say we want to find the value 5 in this list. It's going to enable me to do that and give me back the index position of that value. So if I look at my indices for these values, 0, 1, 2, 3, 4, 5, 6 is the position of the value 5. So if I want to search for 5 in there, I can say numbers dot and press tab and see all those methods available to me, one of which is the index method. And by default, the index method receives as its argument a value to find and tells you the index position of the first occurrence of that value, searching initially from the beginning of the list. So in this case, we do indeed get 6. Now, if the value you're searching for does not exist, you're actually going to get an exception in that case, and I'll talk more about that towards the end of this video. For the next piece, let's go ahead and multiply the numbers list by 2 to duplicate the list, and now we'll have a longer list to work with. So here's the list at this point. Again, this notation is going to repeat the left-hand operand the number of times specified in the right-hand operand and assign the result back to the variable on the left-hand side of the operation here. So this is only when you have a sequence times a value, an integer value specifically. Now let's assume that we want to be able to search from a specific index position. So for this operation, what we're going to do is numbers dot index with 5 and 7 as arguments. The value we're looking for is a 5, and we would like to start searching from index position 7. So before I start counting index numbers, here's the first 5 in the list, here's the second 5. Now if I start counting index positions, 0, 1, 2, 3, 4, 5, 6 is the position of the first instance of 5 in the list. 7 is the first index after that 5. So now I can start a new search that is going to skip over the first set of elements here, start with this value 6 and keep searching forward. So we're going to get the index position 14 as a result of this particular operation. And you also can specify a range of values within to search as well. So if I say numbers.index, and let's say I want to find the value 7 starting from index position 0, which is of course the beginning of the list, and going up to but not including index position 4, well, 0, 1, 2, 3, that's the first 4 elements. Position 4 is where we'll stop our search. In this case, we see that the value 7 is in index position 1, and indeed we get a 1 back. Now, sometimes you don't need to know the exact location of a value within a collection. You simply need to know whether the value is in that collection or not. And for that purpose, we have the in and not in operators. So for example, if we look back here at numbers, we can see that clearly it does not contain 1000. So if I execute the condition 1000 in numbers, I get false because, of course, the value is not in the sequence on the right-hand side. Similarly, if I want to search for the value 7 in numbers, I get true in that case because, indeed, 7 not only appears once in here, but twice in this particular list. And in reverse, we can also use the not in operator. So if I say 1000 not in numbers, then of course we know it's not, so we expect to get true, and we do. And similarly, 7 is in numbers, so if I use the not in operator, in that case I'm going to get false because it is indeed in the collection. Now, these in and not in operators can be used to protect code that might throw exceptions. So I mentioned that the index method of a list is going to return the index position of a value if it's found, but it's going to give you an exception if it's not found. So first let's demonstrate the exception. So let's say we do numbers.index and we search for the value 1000. In that case, we get a value error indicating that 1000 is not in the list. So in Python, it's actually quite common to follow the coding philosophy of asking for forgiveness after a problem occurs, as opposed to coding in advance all the checks necessary to ensure that an exception does not occur at execution time. So one of the things we'll look at in a subsequent lesson is the try statement in Python, which you can use to implement exception handling. And in general, that's the way that most Python programmers will deal with runtime problems if they do occur. On the other hand, every now and then you may find it necessary to write more robust code that prevents exceptions from occurring in the first place. So with that said, let's go and define a variable called key, and we'll give it the value 1000. This will be the value that we're going to search for. And I'm going to grab a code snippet here and paste it in to show you what I'm talking about. So here we have an if-else statement in which we want to check whether key is in numbers, and only if it is will we execute this first print statement, which is going to say found the key at the index position specified by this expression here. So if we already know it's in numbers, then we know the index method will give us back the actual index position of that key value. Otherwise, it will display key not found. And if I execute this particular if-else statement, we get 1000 not found because the key is 1000. So we plug that value in to get the else print result. Now, of course, if I go and change the key to 7, which we know is in there, if I now reevaluate that if statement, that if-else statement, in this case the if part is going to execute because the condition will be true. So we'll plug in the key and we'll plug in the index of that key, and indeed we see that we found the value 7 at index position 1. Now, there are other capabilities for doing things like what we're showing you here. Sometimes you may simply want to know if a given item is true, or whether all items in a given collection are true. You can use built-in functions called any and all to determine that. Now, in Python, remember, anything that is 0 is considered to be false. Anything that is non-zero is considered to be true. So if you have a collection of, say, integers where some of them are 0 and some of them are not, all the 0 positions would be considered false. All the non-zero positions would be considered true. If you had a collection of strings and some of them were empty, all of the empty strings would be considered false, and all of the non-empty strings would be considered true. And if you had a collection of let's say a collection of lists, a list of lists, which is a two-dimensional list, as we'll look at towards the end of this lesson. In that case, for every empty list you would get false, and for every non-empty list you would get true. So again, you have these functions that allow you simply to check whether all of the elements of a collection are true, that's the built-in function all, or whether any of the elements of a collection are true, which is the built-in function any.